Alright, so for this reassessment, we're going to be looking at position, velocity, and acceleration. The problem states from rest, the car accelerated 8 meters per second squared for 10 seconds. Part A is asking what is the position of the car at the end of the 10 seconds, and Part B is asking us what is the velocity of the car at the end of the 10 seconds. So from our position, velocity, and acceleration chapter, we know that our acceleration is our change in position or our change in time. So therefore, if we plug in numbers and everything, we rewrite equations, we can get an equation which looks something like x equals 1/2 times a times t squared. So basically what that means is that a is going to stand for the acceleration of how fast the car was accelerating, which in this case is 8 meters per second squared. So we're going to plug that in for a, and then t is the period of time between the initial and the final position. So therefore, the car accelerated for 10 seconds, so we can write the equation as x equals 1/2 times 8, which is our acceleration, times t, which is 10 seconds, and we square that, and if we plug that into our calculator, we're going to get 400 meters for part A of our equation. So this is pretty simple. This is how we're going to solve for part A of our problem. Part B, if we look, we know that from velocity, our velocity is our change in acceleration times our change in time. So therefore, we can take our 8 meters per second squared in our equation and multiply that by the time it took, which is 10 seconds, and we get 80 meters per second. So pretty simple problem. This is how we're going to solve for our position and our velocity. So that's pretty much it. Very simple problem. Kind of lays down the basic equations for position, velocity, and acceleration.